In this video, we are going to discuss on the topic that is nothing but the basic operations of the signal. So, as we all know, we are not just going to use the same signal that we are getting. For example, if I'm going to place a temperature sensor, or if I'm recording the voice of mine, I'm just not going to transmit it in the similar way which I have received, right? So I have to do some kind of operation. Either I have to improvise the amplitude or boost the signal, or just I have to delay the signal for some time, or sometimes there will be a need for adding the carrier signal along with it. During that time, we are going to make some operations on the signal, right? So in this video, we are going to discuss what are the different types of operation that we can do in a signal. So the first operation that we are going to discuss here is nothing but the time shifting. Okay. So as we all know, shifting is nothing but I'm just going to move an object from one place to another is what I call it as shifting, right? Similar to that, in case of the signal, time shifting here denotes that I'm going to move a signal with respect to time, but the other characteristics of the signal, for example, the amplitude or the phase shift of the signal remains constant, but only I'm going to move the signal in terms of time is what I call it as time shifting. Okay. So there is two different types of shifting that I can do in case of a signal. One is either I could delay the signal or I could advance the signal. Okay. So in terms of easier remembering, I could say that if I want to delay the signal, for example, if I have x of t plus t naught, okay, so if the symbol which I have here below, okay, if it is negative, it can be either negative or positive. If it is positive, then I have to shift the signal, okay, in the negative side, because positive is nothing but I'm going to advance this signal. So I have to move it in before time period. If the symbol in between is negative, it means that I'm going to delay the signal. Okay. So in that case, I have to move it in positive side. Is it clear for you? If it is positive, then it means that I'm going to advance the signal. So I'm going to move the signal in a prior condition. If the symbol is negative, in the axis wise, I'm going to move it in positive direction because I'm going to delay the signal. Okay. That is what we are actually discussing here. So in case of the effect x of t minus 2, I'm going to shift the signal 2 units, and if it is in x of t plus 2, I'm going to move the signal in advance by 2 units. Okay. In terms of real time example, we could see that for example, if I'm recording a speech which is played 3 seconds later than the original recording is what we do. Okay. So let us see a small example which is related to this. Okay. Let us assume that I'm going to have a signal like this. Let me determine that signal as x of t, and it is moving with respect to time t. Okay. So in this case, what I'm going to do is I'm going to move the signal. So x of t minus 2 in this sense, which means I'm going to move this in positive side by 2. Let us assume that the time period of the signal is between 0 to 1. Okay. So here the 0th signal I'm going to add a 2 along with it, and for the 1 also I'm going to add a 2 along with it. Okay. In that case, 0 plus 2 will become 2. So the value which was in 0 has now moved to what place? The second time period. Okay. This is going to be my time period. So if I add 2 along with this one, I'll get 3. So the signal will move to a place of 3 here. Okay. If the amplitude here is 1, the same amplitude will remain the same. Okay. And if I am going to move it as x of t plus 2, in that case I'm going to move it in the negative direction by 2 times. So I'm going to add minus 2 to both of the sides. So the 0th signal will now move to minus 2, and the signal which is at the point 1 will move to the point of minus 3. But the amplitude here is 1 and the amplitude here is 1. There is no change in terms of the amplitude. Okay, so this is what we need in terms of the topic that we are going to discuss is the scaling of time. Okay, so time scaling is nothing but which defines the compression or expansion of a signal. Again, as we are dealing with the time, the compression or expansion generally occurs in the time domain, not in the amplitude domain. Okay, so general mathematical expression could be y of t that is equal to x of a into t. A can be either a term that has to be multiplied or a fractional value that has to be divided. Okay, again, as if in terms of time, as we have discussed earlier, time shifting, in case if the symbol is positive, we have to shift it in negative direction, and if it is in negative, we have to shift it in positive direction, right? Similar to that, in case of time scaling also, if it is 2t which is multiplied by t, I have to divide it by 2, and if it is in terms of division, I have to multiply it. Okay, a real-time example could be something as if I'm going to fast forward a video, or if I'm reducing the time period of that video, no, that will be your real-time example. Let us discuss it with a simple example. Here I have used a signal which is x of t. So now what I'm going to do is, if it is multiplied by 2, I'm going to, if it is divided by 2, I'm going to multiply it. If it is multiplied by 2, I'm going to divide it. Okay. So let us draw the signal. So here the time period is, I'm going to divide the signal. So in that case, I have to multiply the signal in twice. So the value, again the amplitude value remains the same, only the time value varies. So 0 into anything will be 0 and 1 into 2 will become 2. The signal which was initially at the time period 1 will now move to 2 and the amplitude will remain the same. But in case of x of 2 into t, here it is multiplication. So I'm twising the speed, so the time should reduce. So what I'm going to do is, I'm going to divide the signal by 2. So 0 divided by anything will be the same. So 1 divided by 2, the signal will now get compressed to the time period of zero point 0.5. Okay, so here the compression is done, but the amplitude will remain the same. Okay, so the next thing we are going to discuss is nothing but the amplitude scaling. Okay, so as the name itself denote, I'm going to scale the signal in terms of amplitude. So the height of the signal only varies, nothing other than that varies. Okay, so again the mathematical expression, here you can see that the difference between time scaling and amplitude scaling is x. In case of the second case, time scaling, it is x of a into t, because I'm going to do every operation in terms of time period. But the amplitude of the signal we generally use to determine it before the signal, right? So that is why I have defined y of t that is equal to a into x of t. So if the amplitude value is greater than 1, then the amplitude increases, less than 1, the signal gets scaled down. Okay, so here it is direct meaning. If it is 2 into x of t, I'm going to multiply the amplitude by 2. If it is 0.5 into x of t, I'm going to multiply the amplitude with 0.5. If it is 1 by 2 into x of t, I'm just going to divide the signal by 2. That's it. There is nothing indirect meaning and all. Okay, the next basic operation that we are going to discuss is nothing but the amplitude shifting. So amplitude shifting is nothing but, I'm going to either move the signal up or down. Again the shape of the signal remains the same, there is no changes. So general mathematical expression is y of t that is equal to x of t plus c. So if x of t plus 2 is, I'm going to shift the signal 2 times up, I'm going to shift the signal 3 times down. That's it. Nothing other than that. So here, in case of real-time example, if I'm going to add a DC offset to an AC signal, these kind of operations is generally done. So the next basic operation that we do is nothing but the addition of signal. Just I'm going to add two different signals. And again, in case of this concept, whenever I want to add two different signals simultaneously by using a microphone, These type of operation is what we generally do. Okay, so let us discuss this operation with a basic example. So I'm going to consider two different signals here. Let us assume that this is my first signal. It starts at the point 0 and the time period 1 is what it is ending. I'm going to represent this signal as x of t. Okay. So the second signal is something like this, which is a triangular signal. So I'm going to represent it as x1 of t. Okay. So again, it is going to vary with respect to time, and the range of the signal is between 1 to 2, and the amplitude of the signal is 1. Okay. To add both of these signals. Okay. So when I add both of these signals starting from the point 0, at the point 0 the amplitude of the signal is initially 1. Okay, for the first signal, and for the second signal there is no amplitude actually. Okay, so until 1 the amplitude of this signal is 1, so it is going to remain the same. But at the point 1 the amplitude of this signal is actually 0, and it starts increasing gradually, right? So at the point of 1.5, let us assume that the amplitude of this signal is going to be what? 1. But at 1.5 I don't have a signal, right? So it is going to remain at the point 1, the amplitude of the signal is going to be 1. Okay, at the point 1.5 actually what happens is, after the point 1 the signal starts increasing gradually, right? And at the point 1.5 the signal's amplitude is going to be 1.5, sorry 1. After 1.5 time period the signal's amplitude is starting to decrease gradually, and it reaches the point 0 at the time period 2. Okay, this is what the actual addition